right?
Yes, sir. Recording has been started, sir.
Okay, good. So, very happy New Year to everyone, and I welcome you to this course. Hope you can all see me clearly. I have to hold the tablet in a proper way, otherwise you don't get a good angle. Okay, so uh, my, as you know, my name is Purandar Bhaduri, and I'm the instructor for this course, CS 205. And the title of the course is Formal Languages, Automata Theory, and Computation. So let me start by switching to the whiteboard, right? And I still need some practice with that. So let me get started. So I have to share the screen and start broadcast. And then I have to go to notes, right? So this is the title of the course. And sorry, the course number. And the title is Formal Languages. Automata Theory and Computation. Right. So I hope all of you can read what I've written, right? And I'm getting some static noise, so maybe all of you should turn off the audio. Unless the static noise is coming from my, yeah, okay. Now it's gone. Okay, good. So you can all, I hope you can all read this. If you feel, you can stop me at any time. Okay, so please don't hesitate to do that. You can raise your hand, and uh, the TAs will interrupt me. Okay, so please do that when you want to stop me for any reason. If you want to ask a question or any doubt, or something is not visible or audible, um, please stop me. Okay. Okay. So the first thing is you should do is you should go to the course web page, and to do that, uh, just follow the link from my. Please turn off your audio. Please turn off your mic. I mean. Just follow the link from my homepage. Okay. And you'll go to you can see the link to CS 205 on my homepage, right? And so you'll find all the useful information there. For instance, it's already mentioned that the textbook is by Hopcroft Motwani, and Alman, right? And the edition I have is pretty old. This is 2001. Uh, Sorry, the one I have is 2005, uh, but it really doesn't matter uh, which edition you buy. There's probably a 2007 edition. Okay, so this will be the primary text, but then from time to time, how do I get rid of this? From time to time, I'll also refer to the older version of the book, which is by Hopcroft and Ullman. This is the original book. And this was published in 1979. Okay. What is the difference between these two books? Uh, well, the first book is just a watered down version of the second book. The second book has more material, is more rigorous, and um, uh, it has topics which are missing in the first book. Okay, which were considered too advanced. But then we are an IIT, so we don't shirk away from difficult material. So there are some parts which are missing in the first book, which we'll cover in this class, and I'll mention those things. Okay, most of the material will already be there in the first book. The problem with the second book is it's not easily available. Uh, I don't think Amazon has a version. Uh, you can search for it, but I don't think Amazon has is it's available on Amazon. Okay, because it's a much older version, and it's not that popular because the proofs and the language it's at a more advanced level. Okay, so these are the two books that we'll be using. Next is the grading policy. That is the evaluation and all that. So what I plan to do is have 60% weightage for quizzes and 40% for homework assignments. Okay, and there'll be one quiz every 2 weeks during the class, right? And these will be announced, so no surprise quizzes. Okay, and so approximate, because there are 14 weeks in a semester, so approximately 7 quizzes. Okay, but of course, if needed, I can have more, right? Uh, and the homework assignments. Uh, I don't know how many there will be, but uh, for every topic, there will be some homework assignments. Okay, and you can, for solving the homework problems, you can definitely discuss among yourselves. But when you write it down, it should be in your own language. Okay. If I find that two of you have identical answers, okay, then two or more people, if they have identical answers, they'll all get zero. Okay, so please be careful. When writing the solutions, use your own language. You can have discussions, no problem. Okay. And the next thing is how to interact. If you have other than the class interaction, so how to interact offline, right? And I suggest that we use Teams for all kinds of interaction, unless you want to you want your communication to be private. There's no reason why you should not use Teams. Okay, if you send an email to me or one of the TAs, it'll take more time. Okay, so email responses will take more time because all the TAs and myself will be looking at the Teams chat, okay, for this group. So the chances of getting uh, a response is much faster, right? And moreover, when I share an information with you, it becomes known to everyone. So this is the preferred way. Uh, but as I said, if you want your message to remain private, confidential, then of course email uh, is the only option, and that may take more time. And depending on how many emails we get, we may actually create a new email account on Gmail because institute emails take time and all that. Uh, and there are some uh, restrictions, right? So we can do that if we can create an email account, but we haven't taken a call on that yet. Maybe we'll take it later. Okay, so this is all about the administrative details of the course. And let me pause here and ask you if you have any doubts or any queries at this point. Yeah? Any doubts? Yes?
Hello, sir.
Yes.
Sir, as you say, sir, there may be 7 quizzes. So will be like base 6 out of 7 quizzes will be considered for evaluation, or all will have the same weightage. And so, secondly,
Yeah, I may consider, see, I may do that. I'll take those decisions later. Okay.
okay, sir. Thank you, sir.
And
And
yes, any other? So, what about? I want to say a few things about the quizzes. So, the quizzes may be multiple choice type questions, or they may be short answer type. Okay. And if they are multiple choice type questions, there will be negative marking. So, for if for a question the mark is 2, with a wrong answer, you'll get -2. Okay. But that's only for multiple choice type questions. For short answer type questions, there will be no negative marking. Okay. Any other questions?
and sir, what will be the class mode? I mean, will be recorded lectures or will be live sessions every day?
There will be these lectures every day, just like a classroom. Huh? Now, these lectures are being recorded and they'll also be uploaded, right? Well, they remain in Teams and I'll also upload them to stream, right? So uh, this will be the mode of lectures, okay? I'll be using this whiteboard. No slides. Well, I don't think I'll be using any slides, okay? So this is the way I plan to teach the course. So does it answer your question?
Yes, sir. Thank you, sir.
In case you are unable to connect to the live class because of internet problems and so on, you can always watch the recorded video later on, right? So you have that option. And in any case, you can always do it, even if you attend the class, right? And I encourage you to ask questions, interact, uh, even if you have the slightest doubt, okay? Because online teaching is tough, as you know, and attending online classes is also tough, right? Um, and I hope that this is the last semester in which we have to do this, and from next July we'll get back to regular classes. I sincerely hope that, right? But right now we have no choice. We have to go through this, and it's not pleasant either for the instructor or the students. I know that, right? It's tough for everyone, but we have to go through this. So let's make our task as easy as possible. Okay. So any other questions about the administrative details of the course?
Sir,
Yes.
if we have any doubts, would you prefer that we like open the mic and start talking or raise our hands?
Well, first raise your hand, and because there are 112 students, it's possible that your raised hand may not be noticed. I mean, that's possible. There are just too many students, right? So in that case, you can switch on your mic and stop me. Okay.
Yes, sir. Thank you.
And you can also post questions in the chat. Um, and maybe the TAs, if they notice, they can stop me. So that's another way. I don't know which one works better, uh, but the TAs will be there, right? Because I'm just looking at this screen, right? I'm not looking at the Teams interface. I'm just using this whiteboard, right? So I'm not really looking at who's raising his hand, his or her hand, or who's posting a query in chat. So the TS should do that. But if they fail to notice, you can always stop me. Okay. Anything else? Right. Uh, by the way, you should have hard copies of the book, right? At least the first book. The second book is not so easily available. The first book you should really purchase a hard copy uh, because you need to refer to it. Okay. What is the attendance policy? Well, I'm not taking attendance. right? That's not possible. Okay. But it's for your own good that you attend classes. Okay. Uh, Sharing the notes, I don't know how to do that. I'll I'll see. Uh, I suppose you mean these handwritten notes. Uh, I'll have to figure out how to do that. Right. If I can do that, then uh, no problem. Okay. Sure, I can use it in landscape mode. Will that be better? You think that'll be better? Uh, Now something has come up on the left, so I guess I have to, yeah. Okay, then let me try that, and you can let me know whether this is better or not. Yes, you can always ask me doubts whether you attend the class or not. Well, grading is, of course, relative. Any other questions? All right. So today, in the remaining time, let me just talk a little bit about the course and start with a warm up on cardinality of sets. So, what is this course about? That is, right? And the answer, a brief answer, is it is about the fundamental capabilities and limitations of computers. Okay, so this is a brief answer, but we don't actually study computers in this course. I mean, you have the rest of the computer science courses for that. What we study are models, that is, mathematical models of computation. Okay, that is what this course is about. Okay, so this course is all about mathematical models and reasoning about those models, and these are models of computation. So models of actual computers. Okay, and uh, when we talk about automata, so these are nothing but computers. In a way, these are nothing but computers with constrained memories, as we shall see. Okay. So we will start with the simplest kind of automata, which have only a finite amount of memory, and then slowly increase their computation power by adding more memory And finally, we'll arrive at the general model of computation, okay, which will model a real computer. Okay, so this is the plan. So we'll go from finite automata to push down automata, which use a stack as a memory, to Turing machines, which, as you know, model a general purpose computer. So as we go from left to right, we increase the computational power, okay? And all these, so these are known as machine models, and all these machines compute, these are mathematical models of machines, of course, and these machines compute by taking an input string or an input word, which is just a finite sequence of symbols, and either accept them or reject them. Okay. So the computation is described in terms of language acceptance. And a language is just a set of strings or words or finite sequences. These are all equivalent. Finite sequences of symbols. Okay. So that's what we mean by computation. And as we go from finite automata to push down automata to Turing machines, we get a richer class of languages. And finally, we'll discuss a little bit about complexity theory, which is about computations with bounded space and time. So complexity theory is more about how much we can compute given bounds on the amount of space and time we have, okay, and the mathematical theory behind it. So this is briefly what the course is about. Of course, this may not make much sense now, but just to give you a flavor of what the course is about. And as I mentioned in my email, this is a mathematical course, okay? We don't talk about applications here, although there are applications of all of these. But those applications are part of other courses, okay? In this course, we'll talk about the pure mathematical theory, okay? That is what this course is about. And this is one of the very few courses in the core CS curriculum, which is of this nature. So it'll involve formal proofs of every claim, formal rigorous proofs, just like any course in mathematics, right? So you've done 3 courses in math. You've done math 1, math 2, and math 3, I guess. You've also done a course on discrete mathematics. Okay. This course will be at a difficulty level which is much higher than discrete mathematics. So do you have any questions about the nature of the course? Yeah. Any questions about the nature of the course? Any thoughts, remarks?
Remark.
Okay, so let us proceed. Today, uh, I just want to briefly recall some facts about cardinality of sets. Right? And then this material would have been covered in, in the discrete mathematics course. So the basic question here is, when do two sets A and B have the same size? Right? Well, if the two sets are finite, then it's easy to answer. It's just you just count the number of elements in A and count the number of elements in B, and if they're equal, then they have the same size. But what if the sets are not finite? What what if A and B are infinite sets, right? And in this course, uh, we'll be talking more about infinite sets than finite, right? So, as you know, the answer to that, and this works both for finite and infinite sets, is when there is a bijection bet- uh, between them, right? So, what is a bijection? Well, it is a function or a map, say from A to B, which is injective, also called one-to-one, and surjective, also called onto, right? What is injective? Injective is an injective function maps distinct elements in the domain to distinct elements in the codomain. By the way, A is referred to as the domain and B as the codomain, right? So that means uh, this is all old stuff, so nothing new here, right? I'm just recalling. My God, have to be more dexterous with this. So the way it is usually written is fx equals fy implies x equals y, which is the same as saying this is uh, this is equivalent, right? Because this is just the contrapositive of that. And surjective, and this is of course for all x, for all y, in A. Something happened to the pen. And subjective means for all y belonging to B, there exists an x belonging to A such that fx equals 1. That is, every element in the codomain is the image of some element in the domain, right? So you know all this. And we say if there exists such a function from A to B, we say that it is a bijection. We also say that it is a one-to-one correspondence. So we say that two sets have the same size if there is a one-to-one correspondence or a bijection between them, right? So here are some questions. This is the set of natural numbers. And the natural numbers include 0, right? We always include 0. This is a set of even numbers. So do they have the same size? Are the cardinalities the same? What is the answer to that?
Yes, sir.
Yes, because we know that there is a bijection, right? Which maps x to 2x, right? And you can check that this is a bijection, right? It is injective and it is surjective. So although the set of even numbers is a proper subset of the set of natural numbers, the two are actually of the same cardinality, right? So when we go to infinite sets, there are things which are not so intuitive, right? What about, so this is 1. What about the set of natural numbers and the set of integers? And the set of integers include all the negative integers as well as all the natural numbers, right? So what is the answer to that? The answer is again yes, right? Because we can enumerate the set of all integers in this way. We start with 0, and then we write -1, then we go to +1, then -2, then +2, -3, +3, and so on, right? So this is the mapping from, this is the mapping from the natural numbers to the integers, right? So 0 will be mapped to 0, 1 will be mapped to -1, and 2 will be mapped to 1, and so on, right? Very often we don't bother to write this mapping, we just enumerate the elements, and this is an enumeration of the set of integers, and we can see that in this enumeration no integer will appear more than one. Every integer will appear exactly once, right? I mean, and nothing will appear more than once, and everything will appear exactly once, right? Which is to say that this mapping is both injective and surjective, okay? Right? So we know all this. So another way of saying it is any set which is in one-to-one correspondence with the natural numbers is called enumerable, denumerable. Or countably infinite. Okay, so anything in one-to-one correspondence with the natural numbers, right? And we use the word countable to mean either finite or countably infinite. Okay, the TS will note that. Okay. So the next question is the set n cross n, that is the set of all pairs of natural numbers,
Hello, sir.
yes?
Sir, there is a query in the chat box.
Yeah.
Why
Yeah.
0 is included in set of natural numbers?
Yes, it is always included. 0 is always included. Just go, if you go back to the piano axioms for natural numbers, they say 0 is a natural number and the successor of a natural number is a natural number, and so on. There is a number of axioms, right? And it is natural to include 0 in this set for many reasons. Right? One of them is you want an identity for addition, okay? But that's not the only. Okay, let's proceed. Uh, so this is just the n cross n is just the set of all pairs of natural numbers, right? So is it enumerable or can you put it in one-to-one correspondence with the natural numbers? Again, the answer is yes, because if you think of this two-dimensional table, right? So this is the first row. In the first row, the first element of the pair is 0, right? In the second row, the first element of the pair is 1. So think of this infinite two-dimensional table, which is really the set of all elements of n cross n, right? And we have to come up with an enumeration of all these elements in the two-dimensional table. And the way to do that is to start from 0, right? 0, 0. And then 1, 0, 0, 1, enumerate these, and then, and so on, right? So if you look at the enumeration, it's really 0, 0, 0, 1, 1, 0, sorry, 1, 0, 0, 1. and so on. So you know that every pair of natural numbers will appear in this enumeration. Because if you notice, uh, the sum of the two components keeps on increasing. First, the sum of the components is 0. Then the sum of the components is 1, right? Then we come to the list where the sum of components is 2, and so on, right? So every pair will appear somewhere, and no pair will be repeated. Okay? So we have an enumeration, right? So that's also enumerable. What about the rational numbers? What is happening here? Something wrong. So what is a rational number? This is the number of the form. So this is a rational number. This is of the form P over Q, where P, Q are integers, and Q not equals 0. So are these enumerable? Well, yes, using the same technique as this one here, as pairs uh, of natural numbers, but you have to be slightly more careful here. First of all, 0 will not appear in the denominator. So if you construct a two-dimensional table like this, first you consider all the rational numbers whose denominator is 1, right? So, and then, of course, I forgot 0. So 0 is a rational number, right? So here you'll have 0 over 2, 0 over 1, 0 over 3. Sorry, got it wrong. So everything here has a denominator of 2. Sorry. This will be 2 over 2, and this will be 3 over 2, and so on, right? Now, we have to be slightly more careful because some numbers have appeared more than once. So 1 over 1 is the same as 2 over 2, and so on, right? So there'll be many repetitions. So we'll enumerate them in the same order. But whenever there is a repetition, what is this about? Live broadcast to Microsoft Teams has stopped due to someone else started sharing. So let us continue. So when you come to this row, oops, when you come to this diagonal, you don't include 0/2 because that has already appeared, right? So you just drop those which have already appeared in the enumeration. And this way you get an enumeration of all the irrationals. So no problem. Uh, Now let's come to the real numbers, and that's really what I wanted to get at. So this is the set of real numbers, right? And it includes not just the rationals, but irrationals as well, right? So the question is this set denumerable? And the answer is no, of course. And there's a famous proof by Cantor, and it's called the diagonalization technique, which we'll be using later in this course for other kinds of proofs, namely computability proofs. Technique or argument. Okay. So what is this argument? Let us briefly recall that. I'm almost at the end of the class. So for simplicity, I want to show that this particular set of all reals between set of all real numbers x between 0 and 1, and 0 and 1 are not included. So we are going to show that this set is not countable or denumerable, right? So how do we do it? Well, uh, the proof is by contradiction. And we are at the end of the class, so we'll take it up in the next class. Um, does anyone have any questions? Any quick question? Well, if not, then let's stop here and we'll continue tomorrow. Okay. Thank you.